Welcome back to 4.2, Proving and Applying the Sine and Cosine Laws for Obtuse Triangles. Okay, so now in 4.2 we're going to take those lessons we learned in 4.1 and apply them to some actual examples. So example 1, don't feel like you have to write down the this part here, the write-up, but I would draw the triangle, okay? So it says in an obtuse triangle, and remember obtuse means it has an angle greater than 90. In an obtuse triangle, angle B measures 23 degrees, and its opposite side B has a length of 40, which we can see demonstrated right here. Side A is the longest side with a length of 65 centimeters. Determine the measure of angle A to the nearest tenth of a degree. So we are looking to find angle A. So still, once again, just like in chapter 3, we have to decide if we're going to use the sine law or the cosine law. We have an angle side pair, so we can do the sine law. So we write down our equation. Sine of 23 over 40 equals sine of A over 65. So here we're going to cross multiply and divide. I'm going to do all these steps on my calculator, as you should be comfortable with them by now. Sine 23 times 65. And then we're going to divide that by 40, which gives us 0. Here I've got sine of 63, sine A equals 0.63493, etc. We're going to take the second function of that. And for A, we get 39 degrees. Now, we can tell, looking at our diagram, that angle A is markedly bigger than 39 degrees. It's an obtuse triangle with an obtuse angle, so now we have to rely on our ratios we learned in 4.1. So we say, okay, well, 180 minus 39, 141. Sine of 39 is equal to sine of 141, so angle A is actually 141 degrees, which is a lot more realistic given our diagram, okay? And basically all the questions, it's fairly easy to tell if that angle is realistic or not. All right, let's take a look at example 2. Example 2, I have the diagram here for you. The write-up is in the textbook if you ever wanted to look at it. It tells you that angle BJC is 7 degrees. This one here is 7 degrees. Angle or side length B is 250. As we can see, it's opposite of angle B. And this question, what it deals with is the height of a balloon. So here's a balloon up here. But what we've got is we can see that this angle right here is greater than 90 degrees. This is an obtuse angle right here. Okay? So what we have to find, we're given that this piece right here, from the ground up to here, let me do that in the highlighter. This one here is 82 degrees. So the first thing we do, because right now in our triangle we don't have enough information to solve anything. Eventually they're going to want us to find the height of this balloon is our long-term goal. We're not there yet. So if this angle here is 82, that means that angle JCB, let me write that up here. Angle JCB is 180 minus 82, which is 98 degrees. So we know that this angle right here is 98 degrees. Now we can see in our triangle that we have two angles, right? We have this one is 7 and this one is 98, so we can find the measure of angle B. So now I can go 180 for the triangle minus 7 and 98, which are my two given angles. And that means that angle B is 75 degrees. Now that I know that angle B is 75 degrees, now I have my angle side pair, right? Between angle B, 75, and the opposite side, which is 250. I can use that to find the measure that I really want is this one right here. So my equation for that would be 250 over sine 75 equals x, or I could have called it j, whatever, this right here, over sine of 7, as 7 is the opposite angle to this side. So this is just a quick sine law cross multiplication. You will get that x is 31.542. Now, we're getting closer to our answer, but we don't quite have the angle. I'm going to draw this again so you can see it a little bit better. I'm going to make it a little bit bigger. This is this piece right here. Let me highlight it in blue for you. This is this triangle right here. Okay? We just found out that the hypotenuse to this is 31.542. We can see that this angle here is 90 degrees, and we want this height. We want this height of this balloon, just straight up and down, okay? Well, we know that this angle right here is 82 degrees. We were given that from the beginning. This angle was 82 degrees. We have a right angle, so we can use the primary trigonometric ratios to find the height. Opposite and hypotenuse means we get to use sine. Sine of 82 equals h over 31.542. The h is on top, so we multiply and round it to the nearest meter, what the question had asked for. The height would be 31 meters. So the height of the balloon is 31 meters. Okay. This one was a little bit trickier with a diagram that was a little bit more complicated to read. But if you go back and watch this one again, it'll probably make a little more sense the second time through. Okay. Let's try number 3. I believe we have 2 more. No, a couple more. All right. Here we have a house, okay, and we're looking at the roof of the house. And I'm going to draw you the triangle separately, so it's a little bit easier to see. The question wants to know, so we've got the length of these sides of the roof are 17, this one is 20.3, and this one is 33.5. The question says, determine the measure of the angle used for the roofing cap, which the diagram tells us is right at the top. So we are looking for this angle right here. Let's call this A, we'll call that B, and we'll call that C. Okay. So whenever we know all three sides, that means we're going to be using the COS law. So in this case, it would be COS of A equals 17 squared plus 20.3 squared minus 33.5 squared divided by 2 times 17 times 20.3. Okay. So we start to calculate this. 17 squared is 289. You just did a number of these on your Chapter 3 tests, so I'll just push through the opening part. Now, one thing you may be noticing is that we're going to end up with a negative number on top. When we go 289 plus 412 minus 1100, we're going to end up with a negative value to deal with our COS. But that's okay, because as we learned in 4.1, the negatives are sort of to be expected when you're dealing with COS and obtuse angles. So 289 plus 412.09 minus 1122.25 equals negative 421.16. I'm going to divide that by 690.2, giving me a COS of A equals negative 0.610199942, etc. Okay? And again, if we want to find the angle, right, we go second function COS, so COS minus 1. Rounded to the nearest tenth of a degree, you can see that we got an answer of 127.6 degrees. And if we look at our angle, we can see that this is an obtuse angle for A. So 127 is a value that makes sense there. Okay? So the fact that we had the negative there was not a big deal, because once we took the second function COS, it gave us an answer of 127.6, which is an acceptable answer. Next up, let's take a look at how many are left. Well, we got a few to go here. Okay, let's get you to try this one on your own. Okay, so here we are looking for the length of side X. Okay, you have an obtuse triangle with an angle of 101 degrees. I'd like you to find me the length of side X. So I'll give you 2 minutes, and then we'll look at the answer. All right, I'm going to start putting the answer down here. You can just take a look up when you've got it. Here I have an angle side pair, so I'm going to do the sine law. 4 over sine 28 equals x over sine 101. Cross multiply. 4 times sine 101, 3.926 divided by sine 28. You're getting that x equals 8.36. If we're rounding to one decimal place, it would be x equals 8.4. Okay? Hopefully there was no issues with that one. It's just a mostly basic sine law. Next question. I will skip that one for now. Let's try this one here. Because this one forces us to draw our own diagram, and sometimes these ones are important to attempt. It says the posts of a hockey net are 6 feet apart. A player attempts to score by shooting the puck along the ice from a point that is 21 feet from one post and 26 feet from the other post. Within what angle must the shot be made? So obviously we know that we need a triangle, right? All of these questions have triangles. So I start writing down what I know. This distance right here is 6 feet. This is our goalie net. I can't draw a net. If you're welcome to try if you'd like to. This is our net. Now, they're saying that he is 21 feet. Well, let's try that again. 21 feet from one post and 26 feet from the other post. And the question says, so here's our hockey player right here, right? Within what angle must the shot be made? So we are looking for this angle right here. Within what angle must he shoot in order to hit the net? So this is a side, side, side. So that means we're going to use the COS law. So I'm going to call this side A, call this B, C. Okay? So it's going to be COS of, I'll move that up. COS of A equals 21 squared plus 26 squared minus 6 squared divided by 2 times 21 times 26. 21 squared is 441. 26 squared is 676 minus 36 divided by 1092. Okay, the rest of this I'm going to do on my calculator. 441 plus 676 minus 36 is 1081 divided by 1092. COS equals 0. COS of A equals 0.9899 9, 2, 6, 7, etc. Second function cos. We are given that the cos of A, he has 8 degrees to make this shot. Now, in this case, maybe 8 degrees doesn't seem like the actual length, but again, we drew our own diagram here without knowing exactly where the point should go, so not a big deal. But in this case, he has 8 degrees with which to make that shot. Okay? I believe there's one left. Yes. Okay. This is a good one to try. It says a telephone pole is beginning to lean as the soil erodes. A cable is attached from the top of 5 meters from the top of the pole to prevent the pole from leaning any farther. The cable is secured 10.2 meters from the base of the pole. Determine the length of the cable that is needed if the pole is already leaning 7 degrees from the vertical. Okay, I'm going to help you with the diagram on this one, as the diagram is given in the textbook, but I wanted to go through it with you. So, here is our telephone pole. Normally, the poles we would draw would be straight up and down, right? But in this case, it says the pole is beginning to lean. So we're going to have our pole slightly off center, slightly up and down. And this is 15 meters high. The pole's 15 meters high. Now, it tells us that a cable is attached 5 meters from the top of the pole. So 5 meters from the top of the pole is like right there. So this little piece here is 5. This cable goes all the way down to the ground. Okay? The purpose of the cable is to prevent the pole from leaning any further and falling over. The next step is that the cable is secured 10.2 meters from the base of the pole. Well, finish our triangle, obviously. 10.2 meters from the base of the pole is where the cable attaches. So our bottom length is 10.2. The question wants us to find out what is the length of this cable. Now, the last thing we need is that we don't have any angles at this time, right? And we're going to need an angle if we're going to find that side length. So we are told that the pole is already leaning 7 degrees from the vertical. So if this pole was straight up and down, right? If the pole was straight up and down, it would make an angle of 90 degrees with the ground. But the pole's not straight up and down. The pole is 7 degrees from the vertical. So that means that this angle here is actually 97 degrees. Okay? If it was leaning straight up and down, it would be 90, but it's not. It's got that slight lean to it, okay? Now, as we go to make our triangle, there's one more thing to point out. This length right here, this entire pole is 15 degrees, right? But we don't need that 15 degrees in the triangle because we're not using the entire pole in the triangle, right? Because this cable is attached right here, 5 meters from the top of the pole. So the actual distance that we need for our triangle is 10 meters. The 15 is the length of the entire pole. That doesn't really matter to us. We only need the 10 meters that is a part of our triangle. So now I can set up my equation. I can go, this is the law of cosine as I go side angle side. So this is going to be x squared equals 10.2 squared plus 10 squared minus 2 times 10.2 times 10 cos 97. Okay, now we start to solve that. 10.2 squared is 104.04. 10 squared is 100. 2 times 10.2 times 10 times cos 97 is negative 24.86. Okay, it goes on a little further, but we'll just keep those two decimals. Here's the important point with this question, okay, and I need you to pay attention to this part. This equation is 10.2 plus 10 squared minus, I'm going to make that in red, minus 2 times 10.2 times 10 times cos 97. But when we did 2 times 10.2 times 10 times cos 97, we got negative 24.86. So what happens if we have two negatives in a row? We have to switch those positive, just like you would have in grade 9. Now it's 104.04 plus 100 plus 24.86. X squared equals 228.9. Take the square root of that. We'll get, once the length of the cable, we'll just do it till 1 degree, or to 1 decimal place. This will be 15.1 meters. And that gets us our answer, okay? So as you can see, a lot of the skills you retain, hopefully from chapter 3, are still applicable. They've just added some slightly more complicated steps when you have to deal with obtuse triangles. That brings us to our assignment. Your workbook is page 90, 234, 789. We are going to have a quiz next class on 4.1 and 4.2. And there was a lot to take in today, so you're going to definitely want to make sure you work at finishing these questions. Thank you. Have a good day.